Hello everyone, it's Yasmin, and in this video, this is the third video of the C++ video series I'm doing. And this video will be starting with pointers. So, a pointer is a variable that stores the address of another variable. It can be used with any data type. And to declare a pointer, we use the asterisk symbol. So, we're going to create an integer variable type and name it age and assign it the value of 34. Now I'm going to create a pointer. So I'm going to declare the the data type of the pointer, which will be integer, and I'm going to name my pointer age. So asterisk symbol. Now use capital A. Now assign it the address of the age I created here, the age integer data type. So now I'm going to dereference the pointer, which means I'm going to display what is contained in that pointer. So dereferencing the okay. So see out. Let's say the age is and let's put our pointer there. And let's display this. So the age is 34. Like you see there. Now if I don't add the asterisk symbol, it will just show me the memory address. So if I copy this line and then paste and then change to let's say the memory address of age is, and then just go ahead and remove this asterisk symbol, so it's just age. So this is the memory address of age. It's a yeah combination of alphabets, three alphabets, and then numbers. So without putting the asterisk symbol in front of it, you are just displaying the memory address. Okay. Now let's make let's make a new line. So now you can also swap the value in the pointer. So let's create two new data types, two new integer data types. My first one will be height is equal to 78. And then my second one will be distance is equal to 100. Now I'm going to create a pointer for height to say int asterisk capital H is equal to, and then assignment operator height, and then we're going to dereference that. So okay, let me just type it out. The height is and then we put height there. Oops. Oops. And then we terminate. Now I have dereferenced height, so it should display the value for height, which is 78. But I want to change it to make my pointer display the value for distance. So for that, I'll say height is equal to, and then I'll assign it, assign it distance, capital, no, sorry, small d. Now, copy that, paste. So I'll change this name here to distance. The distance is okay. Now let's go ahead and run that. Okay. So as you can see, oh, I made a mistake with the new line. Sorry. Forward slash. Right. So now as you can see, the height is 78 and we use the height pointer, but then I changed the address or what the pointer is pointing to distance. So in the second one, it says the distance is 100, even though I'm still using the height pointer. Okay. Okay, so we also have other types of pointers. There's the void pointer, which is a pointer that doesn't have a specific data type. There's the wild pointer, which points to any random memory address. There's the null pointer, and there's the dangling pointer, which points to a memory address that has been deleted. Okay, so now let's move on to references. So, sorry, let's move on to references. So references serve as like an alias for an already existing variable. And the changes you make to the reference also affects the original. So I'm going to create an integer data type and call it weight and assign it the value of 5,000. Now let's display that. Let's say the original weight is, and then and now let's create a reference. So you use the assignment operator and let's name this new weight and say it's equal to weight. Now let's give new weight a different value from the original 5,000. So we'll say new weight is equal to, let's make it 7,000. And okay, so let's terminate this one and this, and let's give a space between them. Yes. Now go ahead and build and run. Okay. So you see, in both of the lines of code where we are displaying it, we used weight, but we are getting different values. It's because we changed the value of the original weight. So using the reference, we changed weight to 7,000, and that's what was displayed here. Okay. You can also pass arguments by reference. So let me create a data type. Let me create a string data type. Let's name it fruits and give it the value, or let's say hold apple, the fruit apple. Now I want to change the fruit from apple to something else. So I'll use modify value, and I'll indicate that it is fruit. Okay. So now I'm going to create a function outside the the int main function. So this will be a global scope. Now I can create it above or below. So for this one, I'll be creating it above. Now I'm going to make it a void. So I'll say void modify value. Make sure I type that correctly. No, it's a small v. Modify. Now let's make it a capital V actually. So let me change this to modify value. Now I'll create a reference for fruits. So I'll say assignment operator fruits curly braces. And in here I'll put the new fruit. I want the variable fruit to hold. So I'll say fruit is equal to, let's change it to banana. Okay. Now we can come back here and then display the value of fruit. So we'll say else the fruit is fruit is and put in here fruit. Now should change the value. Okay, I'm getting an error here. It says banana was not declared in this scope. Okay, wow. So I made a few errors in this. First, I used int instead of string. I've been working with int too much. I should use other data types as examples more often. And then the second error is I did not put banana in double quotes. Remember, banana is a string. Now this should fix the errors. Errors fixed. Now let's build and run. Well, I've got to leave a space. Okay. So the fruit is banana, even though I named the apple. So we used a reference to change the value of the original variable. So from apple to banana. Okay. So that's how references work. Okay, now we are moving on to arrays. So think of arrays as like lists or collections, but they contain the same data type. So they can only contain the same data type. You can't have an int and a float and a string in an array. No. It can only contain int or string or float. And the individual objects in an array are called elements. Okay, so to create an array, first data type. Okay, wait, no. Let's work with something else. So let's say animals. Yes, animals. Now we use the square brackets, which is this, to show the size of the array. Though you can decide not to, but I will have 5 elements in my array. So initialization symbol, and then curly brackets. And then we put in the values. So now if I want to display any of these elements in the array, okay, now also know that arrays, you count the members, you start from zero. So zero, one, two, three. So dog being zero. So if I want to display the element at index zero, I will say animals, and then use the square brackets, so, and then terminate. Let me go ahead and create a line. Okay. Then you see dog being displayed here. Yeah. Now if I want to, okay, let's just copy and paste this to do it. Okay. So we change this to one, change this to two, change this to three, and then the last one, change this to four. So zero to four, that's five. Then we run. Okay, I didn't leave any space between them. Let me do that. Actually, instead of there being a line between them, I want them to be on the same line. So I'll use the slash T line break. Okay. Now build and run. Yes. So you see we have dog, cat, horse, goat, bee all arranged here. Now I can also decide to change I can decide to change the the animal in any of the indexes. So let me go ahead and comment this section. Okay. Now we'll say let's change let's change goat to sheep. So goat is at index 2. Let me say it's equal to and make it sheep. Now we display that. Now goat has changed to sheep. Okay. Now we have different, oh, also seeing as you see how the size of my array is 5. Now what will happen if I try to display the element in index 6, which doesn't exist by the way? So see how it's, let's make this a break. Let's make a break. And let's make this 6. You're not getting anything because it doesn't exist. Okay, let's change it to index 10. Same thing happening because it doesn't exist. Now, know that the way we declared the size of our array here, I could have decided not to put a value there, but the compiler would still know all of these. So if I run the program, I will still get sheep. So you can use this if you are creating an array of unknown size. You don't know how large your array is going to be, so you don't indicate its size. Okay. There are different types of arrays. We have 2D arrays and 3D arrays. A 3D array would look like, so let me say 2D actually. Let's start with 2D. String, let's say planets. And then we'll have two of these. So the first square brackets is for the rows, number of rows, horizontal. And then the second square bracket is for the number of columns, vertical. So we don't really need to indicate the number of rows, but we do need to indicate the number of columns. So let's just give it a simple 3. But also let me give it a 3 here too, equal to now the planets. So we have our 3 elements in the array here. Now we create another curly brace. Now for the sake of formatting and clarity, I'm going to bring this second one down. The curly brace here, open a new curly brace here, and then we case everything in a larger set of curly braces. And then you end that. Now, suppose the we want to display Neptune, which is right in the middle by the way I formatted it. So we say see out planets. Planets. Wheels. Let's create a line break here to leave a space. Okay. Now, yes, so I said we want to display Neptune. This first row is row 0. This second row is row 1. And this third row is row 2. And then this is column 0, column 1, column 2. So we are looking at row 1, column 1. That should work. Row 1, sorry, row 1, column 1. We should get Neptune. Ta-da! Neptune. Okay, let me make this end line. And let me just copy this line. So for Mercury, we are going to column 2, a row 2, column 2, row 2, column 2. And then maybe Venus, so that will be row 2, column 0. And then let's say Jupiter, so row 0, column 2. Now, just to make sure I'm actually getting what I wanted and I'm not getting a different, let's let's add this. Okay, yes. Let's go out and let's go ahead and run that. Right. Neptune, Neptune, Mercury, Mercury, Venus, Venus, Jupiter, Jupiter. So that's how a 2D array works. For a 3D array, there are so it being instead of the size being indicated by two sets of curly brackets of square brackets, sorry, they're indicated by three sets of square brackets. And so it will look like, so if I say string bacteria, because there are many bacteria in the world, like this. This is how the formatting will look. And for the rules. So if I were to make this 2, 3, 3, it means I want to have two columns, well, two sets or matrices that are 3 by 3. So two 3 by 3 matrices. So I'll have what I have up here, two of them. Yeah. And then for how to get a specific index in the array, I give it to you as an assignment to play around with and figure that out. Yes. Okay. Just play around with the different values and then see what you get, and then you get to know how the pattern works. Okay. So we're moving on from arrays to struct. Actually, struct, union, and enum, combining them into one. So struct, sorry, union, and enum. Let's start with struct. So a struct is a user-defined data type, and the elements in a struct are called the members. So to create a struct, actually we create structs globally. So I'm going to go up here. So creating a struct, use the struct keyword, struct, and let's say I want a struct for company, company, company. Now you create a curly brace. Within our struct called company, we're going to have a string, a string for name, as the name of the company, and then let's say an integer variable for number of employees, number of employees. Then we're going to have let's give it another string for goods. Yeah, so I only do these three, but you can create as many as you can, as you want. Now, in the main function, so we call company, and then we give the company a name. Let's say good corp, good corp. Now, to assign actual values to the members that we've created in the company struct, we say good corp dot, and then let's give a name is equal to, let's name, so the name of our company is Good Corporations. Good Corporations. and then dot, let's say number of employees is equal to, let's say Good Corp has 7,000 employees. And then for the last one, dot goods, let's say Good Corp deals with furniture. Yeah. Now to display this, say, or you can say the name is, and then we put in Good Corp, Good Corp dot name, actually, end line. Copy and paste this. Now build and check for any errors. Oh, we have an error here. Right. Delete, delete. Okay. Okay. So now let's build. Yes. And run. It's taking a while. Okay. So ignoring all this, which is our previous work, I should have commented all these. The name is Good Corporations. The number of employees are 7,000. The goods are furniture. The age, oh, sorry, this is from the previous work. So that's a struct. Now let's look at union. But first, let me comment. Let me comment this, which I am not working with anymore. Now we are moving on to unions. Now, a union, unlike a struct, has its members being located in the same memory location, which means it can only display one of its members at a time. So union, let's say union student, it's just like a struct, and age of the student. We use char for gender, so F for female, M for male. Let's say string for the name of the student, and let's create a float for the GPA of the student. Now, let me actually comment the struct since we are not working with it anymore. So, just like the struct, student, student, and then let's give the student a name. Let's say Yasmin. So, Yasmin dot name is equal to, well, Yasmin, and then Yasmin dot, what's the next one? Age, say 34. Now, see out the, okay, the name is, and then Yasmin dot name, which is down here. Wait. Actually, I did not need to add end line to the end of these because they wouldn't be displayed. Right, so back to this. Copy and paste this line. Right. So let's build, check for any errors. Am I getting an error here? It's right. I forgot to mention that union cannot take a string actually. Can't take a string. Union cannot take a string. My mistake. So let's remove name. Let's keep all the other things. And let's build. No errors. And let's run. Now, from the looks, when you look at it, you see we're only getting GPA to be given as a proper value. Everything else is just not giving us what we asked for. This is because the way a union works is it can only display one, and then it chooses the most recent line to run. So because GPA was the last line we coded to display GPA, that is what the program is running. Now, if we comment GPA and then we run the code again, we are still getting weird numbers. And the gender is giving us 3 for some reason. Let's comment the float up here too. And then comment GPA down here too. Now build. Building found no errors by running ha. So gender female. And the age is 70 for some reason. We didn't put 70 there. So it only runs the most recent line and then just gives a random value to the rest. That's how unions work. So structs are better than unions in that they can contain multiple data types, string, bool, and others, and they can display all of them instead of just the most recent line. Okay, now we're moving on to Enum, which is the last thing we'll be talking about in this video. Video has already been extended quite a while. If you notice any cuts, it's because I had to do multiple takes of this one video. Okay, so let me just extend this comment. Extend this comment, right? And then extend this comment down here too. Now we are talking about enums. So to create an enum, use the enum keyword, the curly brace, and then you put in the members of the enum known as enumerators. So I'm actually going to name my enum weather. Yeah, weather. And then we're going to say sunny, cloudy, um, raining, and let's say thunderstorm. Yes. So now we've created our enum here. Now I'm going to use a selection statement. I'm going to use an if else statement. I will talk more about selection statements in the next video. So we're going to say if weather, wait, actually, if, put it in brackets, weather is equal to, say, sunny. So if the weather is sunny, See out. It's a wonderful day. Actually, let's make it long. Let's say it's a wonderful day for a picnic. Let's make it look exciting. Okay, that's too excited. Let's just put a full stop there and end line. Else, so if it's not if the weather is not sunny, then we see out grab an umbrella. Umbrella. Yeah. Now let's give urgency to grab an umbrella. Yeah. And line. So this is our line of code here. So now we've created this, but let's indicate what the weather is. Okay, I realize now that let's change this to actually let's make this climate. Now let's say climate weather. No, actually let's make this today. So climate today is equal to, and let's just make it sunny. So the climate today is sunny. We build, no errors, then we run. It's a wonderful day for a picnic. What if we make the climate cloudy? Build and run. Grab an umbrella. Now we can actually personalize it to make it say a specific thing for each climate. For sunny, it could say it's a wonderful day for a picnic. For cloudy, it could say you should take a raincoat or an umbrella. For raining, it could say um, beware of falling trees. And for thunderstorm, it could say stay indoors. So that would be the if else if statement. And I'll be talking more about that in my next video. But this is where we'll be ending for today's video. Thank you for watching.